Docker support has been recently added to the HPCBOX platform. The HPCBOX platform is a desktop-centric workflow-enabled HPC Cloud Platform that lets you create, manage, and deploy your application pipelines with its workflow-enabled system. It lets you plug in your HPC infrastructure directly into your pipeline, and it lets you scale in and scale out your HPC cluster as part of your workflow. The HPCBOX cluster for Docker supports MPI containers, CUDA containers, and OpenGL containers. It lets you import containers from multiple registries and lets you create workflows combining all these containers along with cluster control operations as part of your application pipeline. So you can import Docker containers from your any public and private Docker registry, including Docker Hub and NVIDIA Container Registry. As an example here, you can see a screenshot of different Docker containers which have been imported into the HPCBOX cluster. Now let's look at a demo and look at the various features offered by HPCBOX for Docker. Once your HPCBOX cluster for Docker has been created, you can use the HPCBOX Connect app to make a connection to the cluster and start the remote desktop tool, which will give you a rich desktop experience on your HPCBOX cluster. You can use the HPCBOX cluster app within the cluster to create, deploy, and manage your workflows. You can see different types of worker nodes here on your cluster. There's CUDA workers, there's compute workers, which are interconnected by InfiniBand, and there's also an NVIDIA based worker for OpenGL. You can use the container admin tool to look at the various Docker containers you've already imported, and you can use the import tool to get in Docker images from other private and public Docker registries. To create a workflow, you can use the workflow editor. You can either use existing workflows or you can create new workflows. In this case, we are going to be using an existing workflow which is going to launch the NVIDIA N-Body benchmark application. You can see the container type is CUDA. The image we are using is the N-Body Docker container, and we are launching one instance in an exclusive mode. Once the workflow gets scheduled, you'll be able to look at the standard output and standard error from the running application. As you can see here, the Tesla K80 was used to run this particular job, and you can see the output from the N-Body application. The next workflow we are going to be running is going to be an OpenGL based workflow. We'll be loading in the OpenGL FurMark benchmark. You can see here that the type of container image is visualization, and we're asking HPCBOX to use an NVIDIA OpenGL based card for graphics rendering. You can see how the FurMark application is started, and it's using the Tesla M60 on the Azure NV6 instance for its OpenGL rendering. We'll also be able to couple different applications together. As an example of this, we're going to be launching the ParaView index server, which has been imported from the NVIDIA Docker registry. We're going to be starting it on NC6 instance for CUDA-based computing. And once the application is started, it will be providing us with a URL which can be used within the ParaView client. So we'll load up the client workflow. And in this case, the client workflow is going to be started on the NV6 instance, which has got an M60, and it's got the OpenGL drivers installed on it. Once ParaView has been started, we'll be able to connect to the ParaView index server, and we'll be able to use that for index-based rendering. So we go to sources, we select wavelet, and after we apply, we'll be able to change the display to NVIDIA index. So as you can see here, we have been able to use images from the NVIDIA Docker registry, and we have been able to successfully use that as part of our workflow on HPCBOX. The final workflow which we'll be running is an illustration of using MPI on the HPCBOX Docker cluster. So we have an existing workflow here which is going to launch the Intel MPI benchmark on 112 CPU cores, and it's going to be running on H16R based instances, which means it'll be using InfiniBand for all the MPI communication. We'll be able to look at the standard output and standard error of the running MPI benchmark. And you can, as you can see here, these are all the results which we are obtaining from running our benchmark on the H16R based compute nodes. It's pretty easy to create a workflow on HPCBOX combining containers of different types. For example, you could create a workflow where the first container is a compute type container, the second container is a CUDA type container, and the third step in the workflow is going to use a visualization or OpenGL based container. So you can chain up all the containers, and you can create a workflow, save it, and you can later run it whenever you please. And as part of the workflow, you can also include cluster control operations, so you'll basically be able to scale out and scale in the different type of worker nodes which you have in your cluster as part of your simulation. Thanks.